Alrighty, I'm Scotty WA2DFI, and I'm going to give you a quick update on HPSDR. Actually, it's a little quicker than it was last night. I had way too many slides, but I still have too many, but I'll try to get through them as fast as I can. I just want to do a quick check. How many people in the audience have HPSDR radios? Oh, not a lot. How many people know what it is, what the project is? Okay, well, I'll try to give you a little bit. For the people who didn't raise your hands, I'll give you a little bit of basic background of what HPSDR is. But I won't dwell on it too long because I really want to focus on the new stuff that's coming. So for those who don't know what it is, high-performance software-defined radio. And SDR in general, as you probably all know what that is, but the functionality of the radio is defined in software as opposed to a software-controlled radio, which most of us are used to, at least in the past. And so we have usually use DSP algorithms in the software or firmware in the SDR hardware itself, like in FPGAs. Best known examples, you've probably all heard of the Flex 5000 or the earlier ones, Flex 1000, and Tony Park's Soft Rocks, good example of software-defined radios. And you've seen the Soft Rock hardware, it's a little thumb drive size unit, and all the hard work's done in the PC. So for HPSDR, what we focused on is high performance. So it's not like a soft rock in that respect, more like the Flex 5000, although it's not meant to be turnkey like the Flex radio is. It's more for an experimenter's model. Based on open source mode, open source hardware and software. So if you're really adventuresome and you not only like to solder down the SMT-ICs, but you like to build your own PC boards, you can do that. All the data is up online for you to make your own boards. Modular and expandable. There's actually going to be one out in the demo area. Or I guess, John, you're going to set it up in here?
We're going to be working in playtime over here, getting ready for Sunday, that people are welcome to stop by and watch.
So the guys are going to be setting up an SDR over on your left along the sideboard there in anticipation of the Sunday seminar, which is going to be now I got all these boards, what do I do with them? How do I plug them in and make them work? And it contributes to the advancement of the state of the art. This is very important, I think, because we're doing things now very leading edge, bleeding edge, stuff that you can't do any other way unless you have lots of money. This is a very low-cost solution for the performance that you get, as you're going to see shortly. So I've kind of covered this already. And this project is run by volunteers. We have people who design boards, who document, who lay out PC boards, draw schematics, build boards, build lots of boards, and TAPR takes care of the shipping and handling the retail end of it so that you can go buy a board and it costs a reasonable amount, because if you built one or two at a time, the cost is prohibitive. So when you build hundreds at a time, get something that's reasonably priced and yet still performs really well. And this is kind of what TAPR's mission here. We support HPSDR with funding for R&D. So say you come up with an idea. So this is a modular approach. It's a backplane that boards plug into. You come up with a great idea that you want to see pluggable into the Atlas backplane. Go on the HPSDR list, run it up the flagpole, see how many people salute, apply to TAPR. Just ask us, stop any board member and ask us about it. We'll be happy to help support your alpha builds because, as you know, the initial builds are typically pretty expensive because you're buying parts in single unit quantities, you're getting PC boards made 2, 3 at a time, and you really have to breadboard these. You have to try them out and test them before you can build 100, or you're going to be in for a real shock. And what TAPR does also is we support early volume production, so when the design is all debugged and shaken out, you know that it's going to work. You've built 3 of them, typically 3 separate guys take them, plug them in, ring them out. Then you want to build 100 or 200 or 500, depending on how many people want them. Then you come to TAPR and we'll provide the know-how to build these and ship them to the individual users. And if you've been on the TAPR site, you actually on the left side you can see the order buttons where you can actually order pretty much all the HPSDR boards. There's a couple exceptions which I'll get to in a minute. So what you get is not just 3 guys, sitting at home tinkering with their PC, trying to make HPSDR work, you get a whole pool of hundreds of people, software guys, hardware guys, guys with ideas, maybe ideas that you didn't think of, or maybe a guy will take your idea and expound upon it, make it better. And as you see, there's some applications to this hardware that you might not have thought of yourself, and I know I didn't think of from the beginning. Like, for instance, you can take a receiver and make a spectrum analyzer out of it. Now, it maybe sounds intuitive now, but wait till you see the performance that you get out of this. You'll be amazed. So HPSDR and TAPR are separate, but we complement each other. So we try to help advance the state of the art. That's kind of what we're here for. We're facilitators. That's what TAPR is. Okay, so now we get into the nitty-gritty of the board set. Again, I took out most of the basic stuff of this because I want to focus on the new things, but I will review this really quickly for you. The Atlas is the backplane. It's a 6-slot, uses an ATX power supply. So you can either use a mini box type supply, or we actually have a supply that will plug into the 20-pin ATX connector. Or if you've got an old PC supply laying around, good luck with the noise that you're going to get out of it, but it'll still work. Pinocchio is an extender. Really don't have a lot of use for that unless you put the entire system in the chassis, and then you might want to have the extender because you can put the board on an extender and get at it while it's operating. The Aussie board is a USB gateway. That's what talks to the PC. That's the interface from the HPSDR to the PC. Janus board, now this was one of the first boards we came out with. That's actually a baseband board. It's a sound card replacement is what it is. But the performance of the Janus board in the SDR application is better than virtually any sound card you can buy. So even if you spend $1,000 on a sound card, you're not going to get one that works for SDR as well as this does. Now, this is kind of an exception because this board here works in conjunction with an SDR 1000 or a SoftRock or any piece of hardware that produces I and Q data stream. Produces baseband audio. So basically, a down converter, whether you use a QSD type converter, or whatever you use, if you get baseband coming in, this is your audio input board. So when we get to these other boards down here, the transmitter and the receiver, you do not need Janus in addition to those. Okay? I want to make that clear because there's some confusion about when you use Janus and when you use Penelope and Mercury. So does everybody understand that? Okay, the Janus is a baseband audio input. It's a sound card, basically. So if you have something like a SoftRock that takes your RF, mixes it down to audio frequencies, you feed it into the Janus board, it's going to work way better than your sound card on your PC. And that's what you use Janus for. But if you buy Penelope and Mercury, those are direct sampling and direct synthesis transmitter and receiver, so you don't need a sound card for those. That's the Penelope and Mercury are a complete transceiver, whereas the Janus really is dependent upon you to provide the front end, the down converter, if you will. Again, Penelope, transmitter exciter, it's a 0.5 watt. It covers up to 6 meters, up to 55 megahertz, and it's a direct synthesis. Okay, and that means you basically take a D to A, and the software constructs the waveform. And then it's followed by a 0.5 watt PA, which I think Phil, he took that from the cell phone industry, so he used like a cell phone type PA, very low power, very cheap too. Mercury uses 160 megasample per second A to D converter. Basically, you connect your antenna to the A to D. That's what it is. Now, it's not quite that simple, but because you do have to have an anti-alias filter, and you have to have, you don't have to. We have a preamp in line also. And we have a selectable attenuator. LPU, linear power unit, this was kind of a stopgap. There is a switching power supply specified on the HPSDR webpage if you look, but it's been under development for like 3 years. So this was a stopgap power supply here, very quick and dirty, just a linear power supply. If you want to heat your shack, this is a good candidate here because it produces lots of heat, and you really need to put a fan on it if you're going to run the entire board set in the enclosure. But it's a quick and dirty solution. It plugs right onto the Atlas board, so it's an interim solution until the fancy switcher gets out. So those are the boards, the basic set. Now, what we have, I'm trying to do these kind of in order of production, in order of availability. Pandora is the enclosure. Those of you who went to Dayton last year, you saw that at Dayton. It was fresh out of the paint shop. brand new. It's available from TAPR now. And this is a really great deal. John Ackerman really took the lead on this. This is a $100 enclosure. And if you see it, it's powder-coated, silk screen, pre-punched for all the boards. And it's really an awesome deal for 99 bucks. Pennywhistle, this is a 20-watt PA. This does not plug into the Atlas bus. This is a small, I don't know the exact dimensions, a small board about this big. And standalone, you could use this for other QRP projects as well. There is room inside the Pandora to mount it on the front panel. This is going to be a kit. I should say it is a kit. N5EN, Steve, and K7WH, Walter from Houston, did the kitting on this. So it uses some, it's like LPU, it uses some SMT parts, but we tried to use some like 1206s and some big parts so as to not scare too many people away. It's pretty easy to build. It's going to come complete with a heat sink, and we'll integrate right, it'll be driven with a 0.5 watt, so it'll integrate right into the enclosure with Penelope. Again, these are going to be available, I would say, within 3 weeks, because right now we're waiting on the heat sinks. We had to have the heat sinks tapped and drilled. And so they say, oh, well, that's great. No, they're not stocked, so 10 weeks. You have to wait. So they're coming in the week after I get back, they'll be in. Excalibur is a 10 megahertz reference. For those of you who a regular 10 megahertz oscillator isn't stable enough, you can use Excalibur to either feed in an external reference, like from a GPS, for instance, very stable reference, or it has an onboard TCXO that you can use. Pretty versatile board. It's a little half-high board. That is in process of being kitted right now. We have all the parts bought, but we don't have we're waiting on the oscillators. Because again, those are made to order because they're very expensive. So Chris Tech makes them to order. So we won't get those until, again, the week after I get back. So we'll be kitting those up. And those, again, that's going to be a kit also. Same kind of 1206 size parts. About, I think there's about 30 parts on this board, so it's pretty simple. For those of you that came to Dayton, Gerd, DJ8AY, has a short backplane. And he also has an antenna switch with or without a 6-meter low noise amplifier, and I'll have a picture of this later. Okay, now the goodies. Gerd's also working on a 100-watt PA. It's not a switched PA, it's a linear type, relatively large board. I don't have any status on this. I emailed him a week before the convention here, and I haven't heard anything back, so I'm not sure where that is. It was supposed to be out right after Dayton, and I haven't heard anything on it, so I have an email address in here later if you want to email him and ask him about it. Put some pressure on him. He needs some pressure. Alex, which is a set of RF bandpass filters, 2-board set, low-pass filters and high-pass filters, so you can use it for a bandpass, basically, by putting both sets of filters in place. The Penelope by itself, the 0.5 watt transmitter, is spectrally pure enough that you do not need any filters. You can connect that PA, 0.5 watt PA, right to the antenna. You meet FCC regulations doing that. However, if you add a PA, you're going to add some harmonic energy. You're going to have some filters, and that's what Alex is for. It will handle up to 100 watts, even though Pennywhistle's only 20 watts. We're anticipating a 100-watt amplifier coming out. As some of you know, this is stymied right now because of the toroid problem. There are 43 toroids on this board, and you know how I love toroids, and they're not haven't been my friend this past year. It turns out, I looked at the calendar, it was August 2008 when this was released to me for manufacturing. So I'm way behind here. But we've been going round and round with the Chinese manufacturer to get these toroids built so I can build one of these complete and not have to give you a partial kit and a hank of wire and let you guys wind your own. Maybe I should do that and you can share the pain. The newest one you might not have heard about is Magister, which is, for those of you who have been in the HPSDR world a while, the Aussie board's out of production. Nowhere to buy one. So if you're a new guy and you say, what do I do to get on board on HPSDR? You're kind of out of luck because you can't buy the USB interface. Well, that's kind of an important part. Can't get the USB interface, you can't talk to your computer, so no new people can come and play. So Lyle Johnson has laid this out, a new version of this, and I'll get to this in a second. I'll give you a better description of this than just the bullet item here, but that's the replacement for the Aussie board that you can no longer get. The Phoenix board is a QSD QSE. Now this The QSD and QSE is kind of like the soft rock approach, okay? It's a mixer approach as opposed to the direct sampling or direct synthesis of the Penelope and Mercury. This board has been produced, I think they produced 3 of them. It's in alpha testing right now. They're having a little bit of problem with some spurs on it, so they're still working on that. Hermes, and this is probably the most exciting new one that's coming down the pike, and I got some slides on this later, but this is basically a transmitter section out of a Penelope, a receiver section out of a Mercury, and a USB section out of an Aussie, all cut out and pasted onto one board. So this will be a single board solution here for a transceiver. And now you notice there's a few things missing, like the PA and the filtering. Well, that's what Apollo is. It's going to take the Pennywhistle 15 or 20 watt, depending on who you ask and what day it is. Scaled down low-pass filters, so not 100-watt versions, but only 20-watt versions, and an automatic antenna unit, automatic tuning unit, all on the other board, and it's the same size as the Hermes board. So here you go, a 2-board set. They're meant to slide into a Eurocard type extruded enclosure, and you have a complete radio. And in fact, they even left enough room in the front so you can put like a Beagle board in the front or some such thing to run a front panel if you want to do that. So you can have a single solution. It's got Hermes has a big FPGA. You can put all your processing in hardware in the FPGA, and then you don't need a computer. And they're working on that. I'll get to the status of this in a little bit. Aussie II, this is, we go right on and forth. If you see Aussie II or Aussie II, Phil Harmon is designing this. He lives in Australia, so we call it Aussie II, like in his honor. Or maybe it was his idea, I'm not sure. But anyway, it's a gigabit Ethernet gateway. This is basically an Aussie board that runs gigabit Ethernet instead of USB. So the problem with USB is if you want to, in Mercury, we downconvert all 60 megahertz of the spectrum at once. But you can't send that across USB. That's too high a bandwidth, it's too much data. So what we do is we decimate it inside the FPGA and we send a little chunk across. Well, with this board, now you get a big chunk that you can send across. So that's going to really be exciting when this board comes out. Finally, we'll be able to pump more data into the PC than it can possibly handle. And on the bottom here, this is what I referred to a little bit before, 1 gigahertz spectrum analyzer. I've got some screenshots of this too. This is actually in alpha testing right now. They have a board, and it's pretty exciting. I'm afraid to ask how much it costs because it's got a lot of SAW filters on it and fancy things like that. So, but of course, if you want a 1 gigahertz spectrum analyzer, then you're in the high dollar category anyway, right? So cost is no object. I'll relay that to Phil. You're all in agreement, right? Okay. Some quick pictures. This is the LPU. This is only the stuff that's been released since Dayton. This is an LPU. You see we got carried away with the heat sinks here. They still run pretty darn hot. So the orientation of this is such that when you mount this in the case, the fan sits right back here and it blows onto the heat sink. So I'd like to think that wasn't an accident, but
Inspired engineering.
Inspired engineering, that's right. We can say that now, right, John? Okay, so this is basically the quick specs. The idea is you run it off your station supply, and you can do the math and you can figure out how much heat you're going to get. It's significant. But it plugs right onto the backplane, and it fits within the chassis. So it's a quick and dirty solution. Yeah, Phil designs the minus 140 dBm receiver, and I put a 3-terminal regulator on a board, and that's my contribution. Okay, and this is kind of a little history. We have lots of these kits available still from TAPR, and this is a kit, very easy kit to do. There's a lot of mechanical assembly that is expensive for us to pay a CM to do, so we thought, your labor's free, so we'll let you do it. Okay, and this is a picture of the enclosure. The blue LED fan is not included. I think this was the only one we could find at the Hamster, at the one of the vendors in Dayton, because I brought the thing to the to Dayton, or John brought them, and we didn't have fans. So we had to go and find someone who had fans. And of course, what they sell is like, well, I won't get into that. I don't think LEDs belong in fans, but it's okay. Just like microcontrollers don't belong in toasters. Anyway, so you can see we had a lid here. You can pull the boards out one by one without disassembling the entire thing, so it's a lot better than a DX60 was with the 22 screws on the final compartment. And the interesting part is this is the back panel here. The front panel has nothing on it. So I joke about it. This is the front panel to me because that's what I'm going to use.
Roger Rear, W3SZ, made up a set of back plates for Pandora that have cutouts for Aussie, Penny, and Mercury. And he put a note on the HPSDR list a couple of months ago. He's now received those, sold a lot of them already, but he asked me to pass on that he has probably 10 or 15 sets of those boards, actually 10 or 15 of those boards available. One board provides a backs cover for all three of the basic board sets. And if anybody is interested in those, contact Roger directly. While he has that few left, he's willing to sell those.
Yeah. Those are a pre-order, so those are just extra ones that he had made. And in case you wonder, there's 6 openings in the back here, and what we did is we have individual back plates that have 2 screw holes in them and that are solid. That's what comes with Pandora. So when you want to put a board in, you just take the plate out and throw it away. You don't use it. But what Roger's done is he said, well, everybody's going to have an Aussie and a Penelope and a Mercury. So he took those 3 cutouts and he made a single plate that's, I think it's 4 wide actually. And he put the cutouts in for those 3 boards. So you can take 4 of your plates off and mount this on the back, and you got a great escutcheon that lets just the connectors show through. So you get a little bit of shielding instead of just having a big open hole there that the boards stick through. But if you want Roger's address, come see John or I afterwards, and we'll point you the right direction if you want to talk to Roger. He did that all on his own, too. Another example of great volunteerism. He just said, hey, I see a need. He paid for it. He ships them all out. The price was reasonable. I think it was, $11 for the first one and $5 for each additional one or something like that? Yeah, including shipping. And they're great. They're powder-coated. They're really nice looking, so impressive. We'll have some. We have some here. So they'll be over on my right here during the playtime. Okay, so basically space for Atlas, LPU, a standard 92 millimeter cooling fan, as standard as that might be. It has room for the Alex bandpass filter board set inside the enclosure, and you actually mount the Alex in its own enclosure inside the Pandora, so you get the shielding of the filters. The removable lid I talked about, individual block-off plates that we were talking about for each slot. And it's pre-drilled for all these extra boards to be mounted. Not pre-drilled for Pennywhistle, but it's made out of relatively soft aluminum. It's made for you to modify, so that's why I did it that way. Okay, they're built by Tentec, and we have lots of these available, so if you're interested, you can get right in. If you have a bunch of boards sitting around, you want to put them in a nice enclosure, this is for you. Pennywhistle, this is a prototype. The production version, the heatsink actually comes all the way down here. But you can see very simple, just a linear design. And this will fit inside Pandora. So you can mount the heatsink on the front of the box and the board on the back. And you're on the air with 20 watts. And these kits will be available, again, shortly after DCC. We're in the final throes now, waiting for just the heatsinks. Runs on 13.6, and by the way, if you have an LPU, there is an internal connection on the LPU just for Pennywhistle, so you don't have to run an extra cable through the back and try to find a place to snake it through. 250 milliwatts drive, 16 to 20 watts, depending on your favored mode. Operates all the way up through 6 meters, about 19 dB of gain. You will need a low-pass filter of some kind, whether you use Alex or something of your own. This is a graph of your power output. You see you do lose a little bit here. You can compensate for this by increasing the drive. Heat sinks are due early October, and then we'll be shipping these, so you'll be able to buy them. These are a great deal, too. I think these are $69 for a kit. So if you compare these for some other places online, like the Backpacker site that have low-power PAs, this is a great deal. You can use this for other things, too, besides HPSDR if you're inclined. This is Excalibur. You can see it's a short board, only like 40 millimeters tall. Allows you to feed in external reference if you like. I don't remember which one of these is which. I think that says in on the top, doesn't it? And then there's a buffered output also for a frequency counter or whatever you like. And this is the TCXO that we're waiting patiently for. And actually, the cost of this TCXO is about 4 times more than the entire rest of the parts that you can buy that are included in the kit. So, okay, so this is kind of an overview. 2 sources, and you get simultaneous outputs. You can drive the Atlas bus, so you can basically run your SDR on this oscillator. And you get this plus 8.5 dBm sine wave on that lower BNC out to your external equipment. And this is an example. That it's hard to see this, but the horizontal lines are 1 hertz apart out of 10 megahertz. So this is about 1/10 of a part per million, 1 hertz out of 10 megahertz. And if you look at the horizontal scale, that's days. So it's not bad, huh?
So that's temperature variation?
No, because it's running at ambient. This is just plotting it over time. And I don't know, did you do this, John, or did Phil do this?
No, that was from K5SO. We did some other tests that actually showed frequency versus temperature. We subjected it to about a 50 C range and tracked all that. It works real well. Short of an oven oscillator, you're not going to find anything significantly better, and it's stable enough that at HF you'll never see whatever drift it has, in the HF frequency range.
Yeah, we have an oven anyway with LPU, right? Just no control loop. So this is another project for one of you guys. Build an oven controller using LPU as a heat source, right? Variable speed fan, you're all set. Yeah, okay. So again, this was Alpha Builds funded by developers. This is, I think Graham did most of the work on the design of this. But again, it's released under open hardware license. We have all the parts in hand. We're going to build, I think, 400 kits, so there'll be plenty of them. And they're going to come out right after the Pennywhistle comes out, as soon as I get the TCXOs, and I can twist somebody's arm into kitting them. So if you got some free time, you want a kit, come see me. No toroid. Oh, there is one toroid, but this is a kit, so you don't have to wind anything. You get to wind the one toroid. Didn't want to deprive you of the happiness. Okay, real quick down through, Penelope is not available from TAPR anymore, but GERD sells this, and actually you can buy it on eBay. Just go into eBay and search for HPSDR, and you'll come up with his boards. I haven't actually seen this one on there, but I've seen the antenna TR switch and the LNA. He has 2 versions, one with the amplifier and one without. 100-watt PA again, I don't know what the status is of that. He was planning that before Dayton this year, but I don't know what progress he's made since then. And I got some pictures here. This is the LNA. And the LNA is this, I think I can see this. This is a board that plugs in. So it's optional. You can use it or not. So again, it's either external, or I guess you could mount it in Pandora if you wanted to deal with that. This is a standalone LNA in a box. It's not very exciting to just look at the outside of the box, but you can put this module here in its own box and just use it as an amplifier. And this is a picture of his prototype PA. You can see the PA transistors here. And it has a processor on it to monitor temperature and current and SWR, so it's kind of an intelligent PA board. Be interesting to see what he's done with this. Okay, now for the fun part. Here's your toroids. Toroids are your friend. The other thing that's your friend, notice all these? These are relays. That's what makes this so expensive. This board set's going to cost about $450 because there are tons of relays and they're expensive. And interestingly enough, the price does not come down that much with volume, as in, like with semiconductors, when you get lots of volume, you get a much better price. Relays, it comes down like 3%. So it really was shocking to see how little it came down. And this includes a preselector, transmit low-pass filter, and an integrated 6-meter preamp, and the TR switching integrated also. It's a 2-board set. This is the front of the transmitter board, I think. Let's see. Well, this is the features of the board set. Okay, so you get high-pass filters for the receiver, low-pass filters for the transmitters. This, incidentally, is the same size the Hermes is going to be. Fits in the same type of enclosure. And if you see this, whoops, if you see this here, this is an extruded aluminum enclosure that the boards slide into, and then a plate slides over the top. And then 2 end caps go on. You've got a fully enclosed shielded box. It's controlled with a SPI bus, and there is a port on Mercury to control that. There's also going to be a port on Hermes to do that also. So they're planning ahead, planning to be able to use this in case you don't want to use the Apollo, the cut-down, low-power one. You can use a full Alex for this, so we can ever figure out how to make them. And you can operate them standalone. Graham has actually designed up a little pick board with an LCD on it, which allows you to use buttons, and you can cycle through the different bands in a standalone mode without having anything connected to it to control it. And one of the reasons they used big inductors was no degradation of IP3. I know Phil tried really hard to make this small and use smaller inductors. He wanted to use solid-state switching of the filters. They just could not do it. They actually breadboarded some of this, and they could not make it work without degrading the performance. And, of course, the HP and HPSDR is high performance, so we don't want to put that on the front end of your really high-performance radio and, have it sound like a soft rock. No offense to Tony. Soft rocks are great, but not when you pay all the money for this. You want it to be performance-oriented. Got 3 antenna connections, so, it's kind of sort of a station console integrated in. Only thing it doesn't have is an ATU. It does have forward and reverse log amps for RF power measurement, and there's a port on, I believe it's on Penelope, where you can actually read the forward and reverse power from the Alex board in software. And you can also, these are basically discrete filter elements, so if you decide you want to transmit on 50 meters, wherever you want to transmit in this range, the transmitter and the receiver don't care. There's not any tuned circuits on Penelope and Mercury. This is your tuned circuits. These are your tuned circuits. So you can change the components in those filters, and you can select whichever ones you want. Kind of a custom. So buy 2, and then you can make the second one custom. You'd probably just like to buy 1, wouldn't you? I think I would. Okay, again, it's rated at 100 watts, so a little bit of headroom over anything that we have today. And if you can read this, you're doing pretty well. This is the block diagram of the transmit board. And there is the transmit board. This back here is the connection back to Penelope, or to Mercury, rather. It's a ribbon cable, so it's a real easy interface. And the receiver board, same kind of deal. These 2 boards actually connect together with an SMA cable between them, which what you don't see. For shielding, we mount the boards in the enclosure back to back so that all the toroids are facing the outsides of the enclosure. So you get better shielding that way, and then we put SMA connectors on the back of each board, and we connect them together, and that's how you can hook up one antenna, and you can do transmit-receive with only one connection, only connected to one board. You also get a 4-step attenuator, too, which is kind of useful. And there is the block diagram. And there's the picture. More toroids and more relays. Okay, now here's the timeline. Notice I put this in red because I'm as frustrated as you guys are that I haven't been able to produce this yet. I think I'm getting to the point now where if I can't get the toroid issues resolved by the end of the year, I'm going to go ahead and produce it anyway as a partial kit. So just as a quick aside, how many of you would not wind toroids, would not buy this if you had to wind your own toroids? Anybody? Okay, good. I like it. You're hired. It just got made. The only issue I have with building it without the toroids is I can't fully test it. So what's going to happen then is you're going to have to deal with maybe 1% of the boards will have a bad solder joint or will have some problem, very small percentage. And we will visually inspect them, but unless we electrically test them, we can't guarantee that they all work. So that's been kind of stopping me. I want to make sure I can give you something that you're going to plug in and it's going to work. If I can't do that, I'm a little hesitant. But I think you'd rather have something that you can make work than have nothing. So.
You'll test it in bypass?
Yeah, we could do that, but that doesn't test all of the other 5 bandpass filters, so it'll be partially tested then. And we do pretty well on visual inspection anyway, but there will be something that'll slip through, I can guarantee it. And it'll probably be the guy who's the maddest at me at any one moment. He'll be the guy that gets that board, too. I can just feel it. So production run scheduled for December 09. I hope we make it. Maybe a little bit later than that, but I don't want to drag it on too much further than that because guess what comes after that is Hermes, and I don't want to delay that. Okay, this is a picture of the Magister board. I have one of these out in the demo room for you to see. This is the Aussie replacement. And what we did on this board is we took off all the SDR 1000 interface because we figure everybody who's going to work with an SDR 1000 probably has one of these already. So we don't need to put that on there. We stripped it down. We took off the external power connector. It's meant for Aussie bus, or Atlas bus only use. You just took off all the experimental stuff. So now this is a USB gateway for the Atlas bus, cheap and dirty, just to get us and keep us going until the gigabit Ethernet version comes out, which will probably be mid next year. Probably Dayton time, right? Just in time to panic for Dayton. Okay, uses the same FX2 microcontroller, uses the same FPGA. We did add ESD protection on the USB 2 port because we'd had reports of some people burning up their Aussie boards by accident. So, and there was no ESD protection, so we added that. We retained a few I/O bits for the PTT and the paddle inputs, but no extra I/O for the SDR 1000. And same standard size card. So here's a comparison to Aussie. No software changes on the FX2, no firmware changes on the FPGA. Again, the added ESD protection. We have 2 open collector outputs, 2 totem pole outputs, and 3 inputs to hook to your paddle or your PTT. No SDR 1000 support. We took the DB25 off, and there was a bunch of drivers and resistors and a huge bunch of manufacturing option resistors. We removed all those. No RS-232 ports, although we did run the 3-volt level ports to headers so that you could use those if you want to, but you'll have to provide external level shifting if you want to use RS-232. The 1-wire part, that never worked anyway, so that's gone. That was, incidentally, that was a 5-volt part that got connected up to 3 volts, so it didn't work so well, so I didn't see any reason to keep that. And we took 4 LEDs off. It has 8, of which 2 LEDs, one's power and one's programming complete, so there's really 6 programmable LEDs here, and there are 10 on Aussie. An entirely new PCB layout. And we're going to try to fast track this through because it's really important that we get this done. So if we can get this testing done by the end of October, we can get boards in production by the end of the year. So then new people can play in HPSDR again, which they haven't been able to for about 6 months, 8 months. Ever since just before Dayton is when we sold out. Okay, Phoenix, this is a prototype. Again, what they're having trouble here is the DDS, the synthesizer. They got a lot of spurs on it, and they are having trouble cleaning that up. So Phil, VK6APH, and Richard, VK5BRO, are working on this, and N0TVJAL is helping them, along with Bill, KD5TFD, and you probably recognize all these names if you're on the HPSDR list. Okay, so this is the fun one now. Like I said, what they did with this is they took the best pieces off of Mercury and Penelope and Aussie and pasted them all onto one board, added a 2.5-watt stereo audio PA, and added interfaces to Apollo and to Alex. So if you want to use Alex, if it comes out before Apollo, which I'm hoping it does, you'll be able to do that. And on a 100 millimeter by 160 millimeter Euro card, that'll fit into those standard extruded enclosures that Hammond makes. The schematic's up now on HPSDR reflector. The layout is up next as soon as as the dust settles on this. Kevin's doing the layout, M08KHZ, and he says 2 weeks. I'm going to start an HPSDR pool here. I don't think there's any way he can do it in 2 weeks, but he's very enthusiastic, and maybe he will. It's a hard job, and he's new to PC board layout, but he's enthusiastic, and so we'll see what happens. But it's going to be quick in any case. It might be 3 weeks. That's still quicker than I could do it, so I can't argue too much. You know, he who complains loudest gets to do the next one, or maybe the current one. So anyway, they're working on the layout any second now. This is the block diagram. Again, a nice eye chart here. And the thing that they put on here is since we took these 3 boards and kind of mashed them together, what we did is we took a single FPGA that is the biggest FPGA we could buy that's not a BGA type. So the biggest leaded one that we could get, which is a Cyclone 3C40. And so basically all the components of Aussie, Penelope, and Mercury are all going to be mashed together into this one FPGA, so we picked the biggest one we could get. 3C40 is a pretty big part. And Graham is doing some testing, and this is really, I call it Hermes PA, but that's kind of incorrect. It's really going to go on Apollo. It's going to be on the matching board to Hermes. And he's made some changes from the Penelope PA. You see he's got 2 transistors here. It's basically a tandem connection, which helps you with the gain reduction at 50 megahertz. So you can see what happens. It does drop off a little bit, and I showed this to Phil Harmon. He says, well, you know, you don't have to pay any attention to that because you can adjust the output of Penelope and just increase it a little at the higher frequencies, and you can make this flat straight across. So you really don't lose anything unless you want to. You lose a little bit of gain, but the power handling is still there. The massive ½ watt power handling. Here's the schematic, very simple again. No big heat sinks for ½ watt. There's the top, the board layout. Graham did this. He tried to use large components so it's not too tedious or daunting to assemble. I think the worst part on here is the IC, and it's not bad. 50 thousandths. Pin spacing, there's 2 of them. Everything else is like 1206s or larger. This is basically the Apollo board. This is pretty amazing too because they're going to get all this on one board. They're going to put the 15-watt PA on here, the low-pass filters, and they're based on ALEX. They're not exactly the ALEX low-pass filters. And notice it's only low-pass filters and no high-pass filters on this board. SPI control, same as ALEX is. And the ATU, which is the intriguing part. And they're actually working with Lyle, KK7P, who you all know where he works, right? So he has a little bit of experience building ATUs for Elecraft. So I think it'll work. And it'll be exciting to have all that on one board. Power amp, low-pass filter, and ATU. And same size board as Hermes, mate together, and you'll be able to slide them both into one enclosure. Preliminary schematics under peer review. What they're doing now is they're taking the ATU and they're breadboarding it separately. So they're going to breadboard it and test it separately, and then they're going to integrate it back onto one board. So they're doing separate testing now. It's going to come back together, and then they'll lay out one board. And I think they're being a little optimistic. They want this to come out the same time as Hermes, but from what I see, Hermes is further along than this. And I don't think an ATU design is trivial. So we'll see how it goes, but it should be right on the heels of Hermes. Next in line, Aussie II gigabit Ethernet interface. We're using a Micrel gigabit PHY along with a big FPGA, a 3C40. This will be a high-speed replacement for Aussie or Magister because Magister is only intended to be an interim USB 2 interface to the computer. This is going to be gigabit Ethernet. This is going to give you a lot better bandwidth for the IQ data. Standard Atlas plug-in card. Currently, and I have a picture here, a prototype's built by Phil in Australia. He took the standard card that you can buy, the eval card for this Micro PHY, and he lashed it up to an Aussie board, and he's actually got test frames through the gigabit Ethernet path already. This is the eval board that you can buy, and this is his lash up. You can see the board, and it's kind of lashed on to the front of an Aussie board back here. And he's got this working now. This is his little app that he wrote. You can actually send data out here, and you can receive data out here. Now, I thought that this was a loop back, but I looked for this pattern down here, and after my eyes got undone crossing, I couldn't find it. But it turns out it's not. It's just a way for him to send a packet or look at the packets coming in. He hooked it up to his home network and actually sent data using the new setup. So they're coming along pretty good with that. Cyclops, he's a 1 gigahertz spectrum analyzer, first IF at 1030, second IF at 96, so it's a low second IF. It's for use with Mercury, or you could use Phil Covington's Quicksilver. It does have a second LO output for use with a tracking generator if you so desire. And we have an alpha unit under test now by Phil and Graham. FPGA firmware and the test program are written, and they're doing the detailed testing now, and this is a block diagram of Cyclops. So you can see the first mixer here, second mixer here. It's your buffered output, oscillator output. And that's a picture of it. Notice the shielding traces around. I think this is the IF amplifier here. This is the LO buffer, and these are the two filters. And this is a software program that Phil wrote. This is a 1 gigahertz input at 1 microvolt. So you can see the signal right here using the new test board that I just showed you. Okay, so what's up next? You think, what can we do more than that? Well, Phil says his next project, notice how he hasn't even got the 3 that he's working on done yet. He's already got the next one lined up. He wants to build a signal generator VNA to go with Cyclops, so you can take the output from Cyclops and use this as a tracking generator. And you can use Janus for your ADC input. So that's an interesting use for a board that probably most new HPSDR people aren't using, because it's really used for an SDR 1000. And you can use Aussie Magister or Aussie II for a PC interface. By the time this gets out, I'm sure Aussie II is going to be out, so you can use gigabit Ethernet. Still in the concept phase, but he's still thinking. I wonder when he sleeps, because he comes up with more ideas than I can believe. Another thing that Phil does in his spare time while he's not thinking about new projects or working on the 3 old projects, he came up with this idea of K.I.S.S Konsole. And we all know what K.I.S.S stands for. This must be the Australian spelling of console, I think, because... Anyway, it's a simple, no-frills piece of software. If you want to get into trying to understand what goes on under the hood of your SDR, if you're like me, you go, software, oh, I don't even know where to start even to look. If I wanted to make an LED come on the front of my HPSDR, I don't know how to do that. Well, K.I.S.S Konsole is written in C# using the free IDE, and it's heavily commented. Phil wrote this. It's a no-frills. It doesn't do any fancy stuff at all. The idea is, if you have an idea for what you want to put in your SDR, open this up. You can read the code. You can understand what it's doing. You can add to it. You can modify it. His only request is, when you modify it, comment the heck out of it, so that the next guy who gets it can figure out what you did. Or if you're like me, you can figure out what you did yourself 2 months later because you don't remember. Code's all released under GPL. Full duplex operation with exceptional CW performance. I haven't tried this software, but I'd like to. If I can, once I get Alex built, then I can try it, right? It's currently at 1.06, and he's currently porting the drivers for Vista and Windows 7 support, although I don't know why you'd want to do that, but I guess we all have to have something to do. And this is a picture of the screenshot of K.I.S.S Konsole. So see, you got a waterfall display down here, a spectrum display up here. Pretty nice for a basic software, huh? Okay, that's all I have. And hopefully we'll see you on HPSDR Reflector. Okay, you have some questions?
Just one question. When you run out of Greek gods, do you have a naming convention like they do for, Roman gods? Do they have a way of, like, hurricanes used for a list of names?
Usually
how do you assign the names?
The project engineer decides what he wants to call it. And you notice that they're all called Greek gods except for mine, which is the LPU, Linear Power Unit. I don't know what Greek god to use for that, so LPU, that works. Which god is Pinocchio? Pinocchio? That's not a Greek god, is it? I think Pinocchio is what I am when I tell you when Alex is going to be delivered. All right, cover my nose. Any other questions? All right, thank you.
Thank you, Scotty.